So this lesson is on adding and subtracting rational expressions. Previously we had been working on multiplying, and we even did dividing, where we kept changed. We kept the first fraction the same, changed the division sign to multiplication, and then changed the second fraction to its reciprocal. And then we multiplied the numerators together, multiplied the denominators, and factored and canceled out all the factors. Well, adding and subtracting is somewhat similar, but it's going to take a couple extra steps. Let's first think about what it means to add or subtract in fractions, just regular fractions, not rational expressions. So let's say I had 2/3 plus 5/3. Well, when the denominators are the same, we keep the base. We keep the denominator and add the numerators. So 2 plus 5 is 7 over 3. So 2/3 plus 5/3 is 7/3. So we add the numerators, keep the denominator. But what happens when we have, let's say, 4/9 plus 3/27? They don't have the same denominator anymore, so we can't just add the numerators and keep the denominator. But what we need to get is an LCD, a common denominator. So we have to take our multiples of 9, essentially. So 9, we have 9, 18, 27, and multiples of 27, 27, 40, 54, etc. Well, you're looking for the smallest number that's common with both, and that's 27. So we know our denominator, our new denominator, is going to be 27. Now we don't need to change the 3 over 27 because that already has a denominator of 27. So 4/9, what can I multiply by 9 to give me 27? Well, 1, 2, 3. So 3 times 9. But I can't just multiply the denominator by 3. I don't want to change the value of 4/9, so I have to multiply it by a fraction that's equivalent to 1. So 3 over 3. 4 times 3 is 12. So 12 27s plus 3 27s is 15 27s. And then you simplify as needed. But we're going to use the same idea to add and subtract rational expressions. So let's look at these examples. We have 3 over 2x minus 7 over 2x. The denominator is the same, so we keep the denominator and subtract the numerators. 3 minus 7 is -4, so I have -4 over 2x. Well, can that be simplified? Yes, it can. So we're going to have -2 over x, because 2 goes into 4 2 times. Looking at the second one, I want you to pause the video and try it on your own. Alright, so hopefully you said the denominator is going to be x minus 4. Then I'm going to add the numerators, 3x plus 6. Now, there's nothing I can really do because 3x and 6 are not like terms. I do want you to get into the habit of factoring, though. So 3 times x plus 2 over x minus 4. We can't simplify anything, but in the future we might be able to. Therefore, just get into the habit of factoring now. So let's look at these examples. I want to just find the least common denominator, because really what we're getting into is how to add and subtract with unlike denominators. We have 1/4 and 2/3. So again, if you're thinking about multiples of 4, we have 4, 8, 12, 16, and so on. And then multiples of 3. We have 3, 6, 9, 12, and so on. And our smallest common multiple is 12. So that's what we want the LCD to be. The LCD is going to be 12. Now, all I'm asking you to do here is find the LCD, so we're not going to worry about adding or subtracting these or changing them to their equivalent fractions. But now let's look at what happens when we have a rational expression. We have 14 divided by 4 times x plus 1, and we have 7 over 4 times x. We're essentially looking for the smallest, our keyword smallest, the least common denominator, the smallest multiple that goes into both. So we have 4x and we have 4 times x and 4 times x plus 1. If you look at 4 1/4 and 2/3 from up above, this example, similarly, we kind of thought about this as 2 times 2 and 3 times 1. And we're looking for how many times can I multiply these all together. Actually, this is not even a really good example to make my point. Let me think of another one. What if I had 1/4 and 2/8? Here what I see is I have 4 times 1, and here I have 4 times 2. So I see that the common 4 here, which is good. Now I need the smallest one that goes into both. Now I can multiply 1 times 2 to get 2, but I can't multiply 2 by anything to get 1. So this is really going to be our least common denominator. Take this same idea here. I don't need to multiply either of these by 4 because they both have them. So what I'm really looking for is what can I multiply each one of these by so they have the same denominator. So you're kind of looking for the missing factors of each part. I have an x here that I don't have down here, and I have an x plus 1 down here that I don't have up here. So if I multiply this by x plus 1, both of them now have 4 and x plus 1. But this one still has an x, so I need to multiply this one by x. Therefore, my least common denominator is going to be 4x times x plus 1. And these missing factors are what I'm going to multiply each fraction by in order to get this least common denominator. I think this will be easier to see as we do more examples. So let's look at the first one. 5x plus 2 over 4x squared minus 1 and 4x over 2x plus 1. When you need to find the least common denominator, the first thing you should always do is factor, if possible. And here we have the difference of perfect squares. So I'm going to have 2x plus 1 and 2x minus 1. That's going to replace this factor. Now there's nothing else that I can factor out in the rest of these two fractions. So now I'm looking at 2x plus 1 times 2x minus 1 and 2x plus 1. Well, if I notice, they both have 2x plus 1, but this first fraction has this 2x minus 1 in addition to it. So that's basically what needs to be multiplied into this fraction to get a least common denominator of 2x plus 1, 2x minus 1. So as I said, you're kind of taking the sections, each factor only once. So each factor from each fraction only once, never repeating. That's why in the previous problem where they both had 4, you would take the 4, but you wouldn't repeat it twice because that wouldn't be the least common denominator. Here we're not repeating 2x plus 1 twice. We only need to do it once. But then we need to add in the 2x minus 1. So I want you to pause the video, try this next one. Remember, always factor first, and then see if you can come up with the LCD. Okay, hopefully you've tried this. So the first thing you should have done was factor this x squared minus 6x minus 7, and you would have gotten x minus 7, x plus 1. Because you're looking for what multiplies to negative 7 but adds to negative 6. Nothing else can be factored, so then my LCD is going to be every part of these two denominators. Now we have x minus 7, that's in common, so I only need to write it once. And then we have an x here and an x plus 1 here. So my LCD is going to be x times x minus 7 times x plus 1. Hopefully you got that correct, and we can move on to actual adding and subtracting. So when you're adding and subtracting rational expressions that have unlike denominators, there's 4 steps. Step 1, I want you to find the LCD, find the least common denominator, the least common multiple of each fraction. Step 2, I want you to rewrite each expression using the LCD. So using this new LCD that you found, you're going to rewrite by multiplying by fractions of 1. Step 3, you're going to add or subtract. And then hopefully you can guess what step 4 is. But step 4, you're going to simplify. So first, find the LCD. Second, rewrite each expression using the LCD. Step 3, add or subtract. And step 4, simplify. So let's look at this example using those steps. Step 1 is to find the LCD. Well, I need to factor this first denominator. An x squared minus 4, that's a difference of perfect squares. So x plus 2 times x minus 2. I'm going to replace this denominator with those two factors. Now if you look, the LCD is what's common between both, which is x minus 2, and then all the remaining factors, which is x plus 2. So my LCD is x minus 2 times x plus 2. Well, now I need to rewrite each expression using the LCD. This first one already has the appropriate denominator, so I'm going to have x over x plus 2 times x minus 2. But we need to get this second factor, I'm subtracting, get this second factor to have x plus 2 in the denominator as well. So I'm going to multiply by x plus 2. But if I'm going to do that on the bottom, I need to do that on the top. So I'm going to have minus 2 times x plus 2 over x plus 2 times x minus 2. Step 3, you're going to add or subtract. So we need to first multiply out. We're going to have x minus, now I like to put everything over the denominator. So x plus 2 times x minus 2. And we're going to have x minus, now we're going to distribute the 2, so x minus 2x plus 4. I put this in parentheses because I wanted to emphasize to you that it's minus this whole expression here. So you're going to need to distribute the minus to both. Otherwise, you can also think of it as plus negative 2 and distribute the negative 2, where we would then have x minus 2x minus 4 over x plus 2 times x minus 2. While looking at that further, we have x minus 2x, which is negative x minus 4 over x plus 2 times x minus 2. Now I've run out of space here, but I want you to simplify it one step further because that is our final goal, to simplify. And I want you to take, so I'm going to write my answer up here, take out the negative, and you have x plus 4, so negative of x plus 4 over x plus 2 times x minus 2. You can leave it in your factored form. You don't need to multiply out. There's nothing else we can simplify, so this would be your final answer. Let's look at one more example together, and then I'm going to have you try one on your own, and then we're done. We have x over 3x minus 3 minus x over x squared minus 1. Well, the first thing I want you to do is factor. So I'm going to take out a 3, and I'm going to have x minus 1. Then here I have the difference of two squares, so x plus 1, x minus 1. Now the LCD, hopefully you see, is going to be 3 times x plus 1, x minus 1. So now step 2, I need to rewrite each expression using the LCD. So for this first one, we have 3 times x minus 1. And basically, I'm going to have to multiply each one by x plus 1 to give us that missing factor. In the second one, the only thing that's missing is 3. So I'm going to have to multiply by 3 over 3. Because remember, we're only multiplying by 1 so that we're not changing the value. We're just manipulating it. So I'm going to have x times x plus 1 over 3 times x plus 1, x minus 1. Then I'm doing minus 3 times x, which is 3x, over 3 over x plus 1 times x minus 1. So now, simplifying that, we have distributive property. We have x squared plus x minus 3x all over 3 times x plus 1 times x minus 1. Simplifying that further, we have x squared, and then we have x minus 3x, which is negative 2x, over 3 times x plus 1 times x minus 1. And then to simplify that even further, I'm going to take out an x, and I'm left with x minus 2 over 3 times x plus 1 times x minus 1. Since I can't simplify anything further, that is my final answer. Alright, finally I want you to pause the video and try this problem on your own. Okay, hopefully you've tried it. Let's see if you did it right. First thing you should be doing is factoring. So x minus 6 times x plus 2. It's going to replace that, and 4 times x plus 2 will replace that. Therefore, my LCD is going to be 4 times x minus 6 times x plus 2. So to simplify, I need to multiply this side, or this fraction, by 4 over 4. And I need to multiply this fraction by x minus 6 over x minus 6. And that's going to give me 4 over 4 times x minus 6 times x plus 2 plus 3x times x minus 6 over 4 times x minus 6 times x plus 2. Now I'm going to need to do the distributive property, so distribute this to both, and I'm going to have 4 plus 3x squared minus 18x all over 4 times x minus 6 times x plus 2. Now let's put that in standard form so we can look and see if we can factor. So 3x squared minus 18x plus 4 all over 4 times x minus 6 times x plus 2. In order to factor, I'd have to look at the AC method. So 3 times 4 is 12. So I'd be looking at what multiplies to 12 but adds to negative 18. Obviously, there's nothing that can do that because the highest we can go is 13. So therefore, this is your final answer. If you got that right, then I think you understand this. And on Tuesday, we're just going to be practicing, so you'll get more examples, more problems to work on. Hope you have a wonderful rest of spring break, and I will see you Tuesday.